How did life begin? It's one of the most fundamental and difficult questions, and has challenged us for eons. For years, scientists have been investigating this extraordinary puzzle, trying to figure out how non-living matter could have come together to form a living thing. It's a quest that drives scientists to look for clues at the very ends of the Earth, and even deep into space, searching for the secret of life. Our planet teems with life. From the highest mountain to the deepest ocean, life is everywhere. But how did it begin? How did life emerge on what was once a lifeless planet?
And I think it's just one of those big questions. I mean, people like to know where they're from and how they got there.
Science now hopes to be able to answer this age-old question. Huge strides have been made, and extraordinary theories are now being investigated by some of the world's leading scientists. Some propose that life emerged from a warm volcanic pool. Some suggest it began deep on the ocean floor. And others believe that it developed out in the blackness of space.
This is the time to be alive and working on this field of origin of life, because we now have the confidence that there are scientific ways of tackling the problem, but there's still so many unanswered questions.
We want to know what's on our planet. We want to know what's out there in the universe. We can't help but be fascinated by it.
A first step to understand how life began is to try to figure out where it began. For generations, it was assumed that life began on the Earth. Then, in 1903, the Swedish chemist Svante Arrhenius came up with an outlandish idea: panspermia. His theory is that life was created in space or on another planet, and the seeds of life dispersed out into new worlds. NASA scientist Scott Sanford investigates the possibility that life may have started in space.
Panspermia is not totally impossible. We know samples of Mars have made it to the Earth. So if you had life on Mars, maybe it could have been delivered to us in that way. But even if panspermia did explain life getting started on the Earth, it doesn't explain how life got started in the first place.
Sanford is not convinced that life itself was delivered to the planet, but he does believe that some of the starting materials, the building blocks of life, came from outer space. And their delivery system was a comet.
Comets are delivering building blocks. They're not delivering living systems. They're delivering the components from which you might be able to make living systems.
Comets are made up mainly of water and dust, with traces of carbon dioxide, methanol, and ammonia, all frozen into a giant, dirty snowball. Sanford believes that they also contain small numbers of organic compounds, some of the building blocks of life. But there's a problem. How did they get there? These building blocks are almost always put together by living things. They are complex carbon-based molecules like proteins, carbohydrates, and nucleic acids. So how did building blocks end up on a comet? Unlocking this riddle is the first step to understanding this theory of the origin of life. Sanford suspects that the unusual conditions on comets might lead to the formation of these organic molecules. So he sets up an experiment to test his idea. His first task is to recreate temperature conditions found in space where the comets roam. He has to achieve temperatures approaching -450 degrees Fahrenheit. To get an idea just how cold that is, look at what happens to air when it is cooled to below -300 degrees Fahrenheit.
That's liquid air, basically. And you can demonstrate this by taking, let's say, a balloon, which is simply air in a container.
When Sanford places the balloon in the liquid nitrogen, the air inside it cools, and some of the gases turn into liquid.
And then when I remove it, so you can see the balloon is flat, but as it warms up, it will turn into a gas and blow the balloon back up. This only happens because the liquid nitrogen is at a very low temperature. So if we were to put this nitrogen in the machine back there, it would turn into a solid. So in fact, this liquid nitrogen, as cold as it is positively tropical compared to the kind of temperatures we normally work at when we're doing these simulation experiments. Whoops, we popped it.
Sanford introduces substances found on comets such as ammonia, carbon dioxide, and methanol into his comet simulator. They instantly freeze. The sample is then bombarded with radiation from a hydrogen lamp. This simulates what happens when the comet receives radiation, for example, cosmic rays and gamma rays, and then passes close to the sun. Radiation and heat can transform the simple molecules into an array of organic compounds, ranging from proteins to amino acids. And Sanford uncovers the secret of how this transformation occurs. Some comets pass around our sun in highly elliptical orbits. When they are far from the sun, the molecules that have been irradiated are tightly locked in place, frozen into a solid chunk of ice. But when they get closer to the sun, things warm up and the molecules get a chance to make their move and react.
If you start to warm that ice up so that things can move a little, then they start to find each other and they react. But they don't react with their preferred partner, the person who would make them the most stable. They react with whoever they're next to. So you have these marriages of convenience. And as a result, the chemistry is not the kind of chemistry you think of, in your freshman chemistry laboratory.
Sanford shows how the building blocks of life can be created on a comet. But how do they get down to the surface of the Earth?
A comet can deliver material to the surface of a planet in several ways. Of course, the whole comet could run into the planet, but that's a rather destructive way to do it. But more elegantly is to have the comet shed dust, as we see in a comet's tail, and that dust can then hit the planet's upper atmosphere, slow down without burning up, and then settle down to the surface. We have comet dust raining down on us all the time, even now.
It's an incredible theory that comets can rain down the chemistry set needed to start life. So in February of 1999, NASA launches a bold mission to intercept a comet and return with a sample. It's a chance to test Sanford's theory.
It was recovered nicely from liftoff transients.
After 5 years of flight, the probe, codenamed Stardust, arrives at its target, just behind a comet known as Wild 2. Dust particles from the comet's tail stream into a honeycomb collector filled with a specially designed aerogel. The sample trapped inside the aerogel is now sealed inside the return capsule. 2 years later, in 2006, it slams into the Earth's atmosphere and crash lands into the Utah desert. The Stardust capsule survives the journey, and a team of scientists open it to examine the contents. To their great relief, the mission is a success. The aerogel inside the collector is peppered with tiny particles of comet dust. When scientists at NASA analyze the dust, they discover a vast array of complex organic chemicals, including aminos and hydrocarbons. This confirms Sanford's theory that comets contain building blocks of life.
When you want to make life on a planet, you don't necessarily have to start from scratch on that planet, but that delivered to the planet from outer space may be compounds that can play important roles in getting everything going.
It's amazing to think that life could have been kick-started using organic building blocks delivered from space. But one British scientist thinks that life itself was created on board a comet. Does that mean we are all descended from an alien life form? The search to find out how and where life began has puzzled scientists for generations. Chandra Wickramasinghe, professor of astronomy at the University of Cardiff, agrees that comets had a role in the birth of life. But he believes that life itself began on a comet.
Comets are the best places for life to originate. Our planetary system is surrounded by 100 billion comets. So you are multiplying the odds in favor of life starting on any one of those comets over that on the Earth by a huge factor.
Wickramasinghe proposes that the organic molecules found inside comets came together to make the first single-celled life forms. It's a bold and controversial theory.
At the beginning, we were regarded as heretics, would have been perhaps burnt at the stake if we lived in medieval times. We were certainly mavericks, there's no question about it.
Wickramasinghe's radical claim is that cold, icy comets not only contain complex organic compounds, but also the other essential ingredient for starting life: liquid water. The water forms when radioactive isotopes decay, giving off heat, melting the ice at the center of the comet. In 2005, NASA